Hello everyone and welcome back to exercise number 55 of the SolidWorks Basic Tutorial Series. In this video, we're going to be designing a three-point circular flange. As always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature, but also in creating the base of the component, we're going to be using the polygon tool, and specifically to create this triangular profile. Here we see the schematic drawing for exercise number 55. All dimensions are millimeters. We have the isometric view, the trimetric view. These are two pictorial views showcasing the component at two different angles. We have the top view, the front view, and the section view. And the section view is taken along this line here, line BB. Okay, so this is section BB. So in creating this part within SolidWorks, we're going to follow a feature-driven approach. Step number one involves sketching out the 2D profile for the base right here. All right, in this case, it's a triangular profile with rounded out vertices. So consequently, we have two methods. There are two ways to actually sketch this. Method number one, which is more intuitive and a lot easier, is to use the polygon tool and set the number of sides to 3, creating a triangle, and then rounding out the edges, the vertices of the triangle, with a fillet radius of 17 millimeters. And that will leave behind the basic 2D profile. Also, the origin of the sketch will be right here, all right? So that will be the origin, and we're going to set the distance between the center of the circle, the fillet arc, and the origin as 114 divided by 2, all right? Since this is the overall diameter. Method number 2 of creating this triangular profile would be to sketch out 3 circles, 1, 2, and 3, assign the necessary dimensions. In this case, all 3 circles lie on a pitched circle with a diameter of 114. And then you use tangent lines connecting the 3 circles, leaving behind the basic triangular profile. So we have 2 methods. It's up to you, and theoretically you should get the same result for the mass of the component. All right, so that's step 1. Step number 2 would be to create the circular boss here, the cylinder at the top. And very simply, starting from the origin right here, we're going to draw a circle and define a circle with a diameter of 80 millimeters, and then use the extrude tool right here. If we look at the front view, we see that we have an overall height for the cylinder as 25 minus 10. That will leave us with a height of 15 millimeters, all right? And then we have certain 3D features right here for these 3 mounting points. So again, we're just going to sketch out the basic 2D profile and then use the circular pattern tool to create the other 2 copies, leaving behind the basic 3D profile. And then we have a number of holes. We have 3 holes for the 3 vertices of the triangle. We have 1 larger hole right in the middle, and then 3 equidistant circles on the top face of the cylinder right here. All right. So again, we're just going to be using the extrude cut tool. The modeling process and everything we did ultimately answers one single question, and that is, what is the mass of this part? And here it says that we need to use a material of ASI 1020 steel. So after the modeling process, we're going to assign a material and then determine the mass of the part. So again, this is a relatively simple problem within SolidWorks, and it should be fun. Okay, so with that aside, let's get started with exercise number 55. Okay, so to start, let's go ahead and create a new SolidWorks part. Let's set the background to plain white, and let's copy exercise number 55 into SolidWorks. Drag this upwards, and let's go ahead and make this smaller. All right. So again, step 1 involves creating this triangular base plate, and we have 2 techniques, like I said previously. You could either draw a triangle with the center of the triangle being the right here, the origin of the point, or what we could do is draw 3 circles, 1, 2, and 3, and then define the distances, and then connect the 3 circles using tangent lines. We have 2 methods. It's your choice. You get to choose whatever method you want. For me, I'm going to use the first method because it's more intuitive, okay? And it's a lot easier. So to start, select top plane, sketch. Here, select the polygon tool and set the number of sides to 3. Click on the center of this component and then draw any triangle, right? Any orientation. Click exit, and then click on this point and then set the relation as horizontal, all right? Now what we need to do is we need to assign the fillet radius for each of the 3 corners of the triangle. For the closer here, we see that the corners of the triangle are rounded out with a radius of 17 millimeters. So go ahead and assign a fillet radius of 17. Click on these three edges, 1, 2, and 3. Then click OK. As for the distance, you see here that the three circles, or corresponding to the fillet radius here, are about, or actually lie on a pitch circle with a diameter of 114 millimeters. Now, of course, we have a tolerance here, but we're only going to be using the nominal diameter. All right, so to define that, activate the Smart Dimension tool, and from this point, the origin, all the way to the center of the circle, say that the distance is 114 divided by 2, since we're defining the radius. All right, so now, if we draw a circle from this point all the way to the center of the circle, click on the circle and then say Q for construction geometry, we can very clearly see that the diameter of the circle is by default 114, which corresponds to what we see here on the top view. So this profile here, this full line profile, corresponds to the contour of the base plate. Now, very simply, just press the S key, extrude, and if we look at the front view, we see that for the base of the component, we have an overall thickness of 10 millimeters. So by default, it's already 10. Click OK. All right, so now let's move on to step 2, which is the creation of this boss. So go ahead and click on this top surface, sketch, activate the circle tool, and starting from this origin, draw a circle. Smart Dimension tool, and if we look at the top view, or actually look at the front view, we see that the diameter of the circle corresponds from this edge to this edge, which gives us the diameter is 80 millimeters. All right, so this needs to be 80. Now press the S key, extrude, and looking at the front view, we see that for this section right here, this middle section, it's 25 millimeters minus 10, right? So that gives us 15 millimeters. And then click OK. Now what we need to do is we need to create this protrusion here. We actually have 3 of them, 1, 2, and 3. So it's sufficient that we only draw the 2D profile of one of them, perform an extrusion process, and then use the circular pattern tool to create the other 2 copies. All right. So to start, click on this surface, sketch, click on this circle, convert entities, zoom in closely, and just activate the circle tool. Starting from this point, draw a circle. Smart Dimension, and if we look closely here, we see that from this edge to this edge, corresponding to the diameter of this circle, it should be 26 millimeters. So this is 26. Now activate the line tool and just close off the figure using 2 vertical lines. That's 1 and 2. Use the Trim Entities tool and then delete any extra entities, leaving behind the base profile for the feature. Now just press the S key, extrude boss base. Looking at the front view, we see that it is 15 minus 10. That gives us this height right here, and it's 5 millimeters. All right, and then click OK. Now we need to create the other 2 copies, so very simply just press the S key, select Circular Pattern tool. For the direction, select any circular edge. In this case, the easiest one should be the one here at the top. So the number of copies, the total number of copies is 3, because we have 1, 2, 3. And by default, it selected the last process, the last physical feature we created. So now just click OK. All right. Now if you look closely, we actually have a hole starting from the top face of this cylinder all the way through the component, right? So it's a through hole. So click on this surface, sketch, draw a circle. Smart Dimension, if we look at the section view, we see that the circle here has a nominal diameter of 40 millimeters. So this needs to be 40. Press the S key, extrude, cut. We're using the extrude cut tool. Right-click on your mouse and then select through all both directions, okay? So that will set the end condition. And then click OK. Repeat the same process for the holes here, the 3 holes. So click on this surface, sketch, activate the circle tool, and starting from this point, draw a circle. That's one of them. Smart Dimension. If we look closely here, on the top view, we see that the hole here has a diameter of 14, and there are 3 of them, 1, 2, and 3. All right, so this is 14. Just press the S key, extrude cut. Click OK. The end condition is always set to through both directions. Now we need to create the other 2 copies, so press the S key, circular pattern. For the direction, select the circular edge, and then click OK. All right. Also notice here we have three equidistant holes that lie on a pitch circle with a diameter of 60 millimeters. All right. And each of these holes have a diameter of 10 millimeters. So what we're going to do is we're going to select this top face, sketch, activate the circle tool, and instead of drawing the pitch circle, we're just going to draw one of the circles at any point right here. Smart dimension, and set the distance between this point and the origin as 60 divided by 2, which is 30, right? And the diameter of this hole should be 10 millimeters. Set the relation between this point and the origin as vertical. Now press the S key, extrude cut. End condition is set as through both directions. Click OK. Press the S key again, circular pattern. For the direction, select this circular pattern and set the number of copies to 3, and then click OK. All right, so we have one last thing to do. We need to find the chamfer. So if we look at the isometric view, we see that there are certain edges that are chamfered out, and for the section view, it defines the dimension. So we're following the distance and angle convention. We have 1.5 millimeters by 45 degrees. So just select chamfer here. Set the dimension as 1.5 millimeters by 45, and then click on this line here. That's 1, 2, 3, 4, and 5. These are the edges that are required to be chamfered, and then click OK. All right, so that completes the modeling process. Again, we need to remind you here that we need to assign a material of ASI 1020 steel. Coloring the component is up to you. You can either color the component using the light blue color that I have here, or select any other color. For the sake of keeping this video short, I'm not going to color it, so just go ahead and delete this image. Right-click on material, select Edit Material, select ASI 1020 steel, apply, close. Now for the moment of truth, go to the Evaluate tab, select Mass Properties, and if we look closely here, we have a final mass of 1,127.34 grams. Our final answer is 1,127.34 grams. So it's 1.12 kilograms. We round things up. Okay, so that concludes exercise number 55. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. I hope to see you all in exercise number 56. Until we meet again, bye-bye.